For centuries, we've gazed at the night sky, wondering if there's more out there. Astronomers have long speculated about a hidden ninth planet, far beyond Neptune, influencing the orbits of distant objects. This mysterious world, often dubbed Planet X, has sparked both excitement and skepticism. In 2016, scientists at Caltech proposed that a planet, about 10 times the mass of Earth, could be lurking in the outer reaches of our solar system. They suggested that this unseen giant might explain the unusual orbits of certain trans-Neptunian objects. But how do scientists hunt for a planet that's so far away and so dim? They analyze the orbits of distant celestial bodies, searching for patterns that might reveal the gravitational influence of a massive unseen planet. They also use powerful telescopes to scan the sky for faint objects that could be Planet X. Yet, the search is challenging. The vast expanse beyond Neptune is dimly lit and sparsely populated, making direct observation difficult. Planet X, if it exists, could take between 10,000 to 20,000 years to complete one orbit around the Sun, rendering it elusive to our current instruments. Despite the challenges, the hunt for Planet X continues. New instruments and missions are on the horizon, each bringing us closer to understanding whether this elusive planet is real or just a figment of our imagination. For centuries, we've looked up at the stars, imagining the possibility of planets beyond what we know. Our solar system, with its familiar 8 planets, might not seem like a place of mystery, but there's a deeper story waiting to be told. The idea of a hidden, undiscovered planet has captivated scientists and stargazers for generations. It all started in the 19th century, when astronomers were first puzzled by the orbit of Uranus. The planet's path seemed a bit off, not quite matching what scientists had predicted based on the known forces at work in the solar system. At first, it was a minor anomaly, but the more astronomers studied it, the more they realized something unusual was happening. In 1846, after years of careful observation and mathematical calculations, French astronomer Urbain Le Verrier suggested that an unknown planet might be influencing Uranus's orbit. His predictions led to the discovery of Neptune, a new planet that had been hiding in plain sight. This discovery was a game-changer, showing that even the most well-established models could be wrong, and there was still so much more to learn about the outer reaches of our solar system. But Neptune wasn't the end of the story. After its discovery, astronomers noticed something odd again. Uranus wasn't behaving exactly as expected, even with the addition of Neptune. The inconsistencies in its orbit suggested that there might be another, as yet undiscovered planet further out tugging on it. This idea of a hidden planet beyond Neptune was proposed as early as the 19th century. In fact, it was in 1906 that astronomer Percival Lowell began seriously searching for what he dubbed Planet X. Lowell's search wasn't just about one unexplained orbit. He believed that there was a larger, invisible planet out there that could be affecting the orbits of other objects beyond Neptune. He even thought it could explain the behavior of other distant objects, like comets, and help us understand the architecture of the solar system itself. But despite his efforts, Lowell's search didn't lead to any conclusive discoveries. The mystery of Planet X remained unsolved, but his ideas would continue to inspire future generations of astronomers. In the decades that followed, the search for Planet X faded somewhat into the background. As more was discovered about the outer solar system, especially the Kuiper Belt, a region of icy bodies beyond Neptune, astronomers had new puzzles to solve. Some thought that the unexplained behaviors in the orbits of distant objects might be due to the gravitational influence of smaller, unknown bodies rather than a massive planet. But then, in the 21st century, everything changed. A new generation of astronomers started to revisit the question of Planet X, and with new technology and better data, they began to build a stronger case for its existence. It wasn't just about Uranus or Neptune anymore. Astronomers were now looking at the behavior of entire groups of objects in the outer solar system, objects that seemed to be aligned in ways that couldn't be easily explained by known forces. Enter the modern search for Planet X, a hunt driven by new discoveries and the advanced tools of 21st century astronomy. In 2016, 2 astronomers at Caltech, Michael Brown and Konstantin Batygin, proposed a bold new theory. A massive planet, about 10 times the mass of Earth, could be lurking in the farthest reaches of the solar system. This planet, according to their calculations, could explain the peculiar orbits of several objects in the Kuiper belt, a vast region filled with icy bodies that lies beyond Neptune. What made their theory so exciting was the possibility that this planet, which they called Planet 9, could be the very same Planet X that astronomers like Lowell had speculated about over a century ago. Brown and Battigan's research suggested that the gravitational pull of a massive planet was likely responsible for the unusual clustering of objects in the Kuiper belt, which had been observed by astronomers for years. These objects, including large icy bodies like 2012 VP113, seemed to be in orbits that were all tilted in the same direction, and their paths didn't quite match what was expected given the known planets. In other words, something was influencing the orbits of these distant objects. It was too big to be just a bunch of smaller bodies, and it seemed to be concentrated in a specific area of space far beyond the known planets. Brown and Battigan's research suggested that this unseen planet could have an orbit 20 times farther from the Sun than Neptune, placing it in a remote region known as the outer Oort cloud. The idea was revolutionary, but it also posed a huge challenge. How do you find a planet that's so far out, so dim, and so far beyond the reach of our current telescopes? The search for Planet 9 quickly gained traction, but not everyone was on board with the idea. Some scientists, including those at NASA, were cautious, arguing that the unusual orbits of distant objects could be explained by other forces, such as the collective gravity of smaller bodies or even the influence of other unknown factors. Still, the possibility of a giant, undiscovered planet lurking in the depths of the solar system was too intriguing to ignore, and the search began in earnest. Today, astronomers continue to look for evidence of Planet 9. They're using powerful telescopes like the Subaru telescope in Hawaii and the Atacama Large Millimeter, Submillimeter Array in Chile to scan the sky for faint objects that could be the long-sought planet. They're also analyzing the orbits of distant objects and looking for any signs that could point to the planet's gravitational influence. The hunt for Planet X, now officially called Planet 9, has sparked excitement and curiosity in the scientific community. If it's out there, this planet would be a game changer. It would reshape our understanding of the solar system and give us a glimpse into the mysterious outer regions that we still don't fully understand. But despite all the work, Planet 9 remains elusive. Its discovery would mark a major milestone in the history of astronomy, but until then, the search goes on. The possibility of a hidden world so far from the Sun, one that could be influencing the orbits of distant objects, is a tantalizing idea. Whether or not Planet 9 exists remains one of the biggest questions in modern astronomy, and astronomers are determined to answer it. The idea of Planet X, now often referred to as Planet 9, sounds exciting, but how do you actually find a planet that's possibly 20 times farther from the Sun than Neptune? Unlike Neptune, which was discovered by predicting where it should be and then spotting it with a telescope, Planet 9 is proving to be far more elusive. Scientists don't have direct evidence of it yet, only clues from the way other objects move in space. But that doesn't mean they're giving up. Step 1. Tracking the orbits of distant objects. One of the biggest hints that Planet 9 exists comes from the strange behavior of several objects in the Kuiper belt. Normally, you'd expect these distant icy bodies to be scattered in all directions. Instead, some of them have clustered orbits that seem to be pointing in the same direction. Imagine dropping marbles randomly on the floor. You'd expect them to spread out in every direction, but if you dropped them and they all ended up rolling toward the same corner of the room, you'd start wondering if something was pulling them there. That's exactly what scientists are seeing with these Kuiper belt objects. Their orbits appear to be tilted and clustered in a way that suggests they're being influenced by the gravity of something big, something unseen. By studying these orbits, astronomers can estimate where this hidden planet might be. The tricky part, they have to calculate its possible location based on tiny gravitational nudges spread out over billions of miles. It's like trying to figure out where a bowling ball is rolling in a dark room just by watching how smaller objects move around it. Step 2. Scanning the sky. Once astronomers have an idea of where to look, they turn to some of the most powerful telescopes on Earth. The Subaru telescope in Hawaii is one of the main tools being used in the search. It has a wide field of view, meaning it can scan large portions of the sky at once. Because Planet 9 would be so far away, it would be incredibly faint, barely reflecting any sunlight. Finding it isn't as simple as snapping a single picture. Astronomers take multiple images of the same part of the sky over weeks or months, looking for tiny movements. Real planets shift position against the background stars over time, while distant galaxies and stars stay in the same place. So, if something appears to move ever so slightly across images taken days or weeks apart, that could be the sign of a hidden planet. This method has worked before. Pluto was discovered in 1930 using a similar technique, comparing photographs of the night sky and spotting a tiny dot that moved between frames. But Planet 9, if it exists, is much farther out than Pluto and much dimmer. Some estimates suggest it could be 1,000 times fainter than the weakest stars visible to the human eye. That means astronomers need long exposure times, advanced image processing, and a lot of patience. Step 3. Simulating the solar system. Not all searches happen with telescopes. Some take place inside supercomputers. Scientists use simulations to model how the solar system behaves with and without a ninth planet. They input everything we know about gravity, planetary motion, and the known objects in the Kuiper belt, then tweak different variables to see what fits. When they add a large, distant planet into the model, suddenly, the weird orbits of Kuiper belt objects start to make sense. It's like finding the missing piece in a jigsaw puzzle. But simulations aren't enough to confirm Planet 9's existence. They only show that it could be there, not that it is there. That's why direct observation is still the ultimate goal. Step 4. Looking for unexpected clues. Astronomers are also searching for indirect evidence, things that might hint at a massive planet hiding in the shadows. One idea is to check for how Planet 9's gravity might affect other things in the solar system. For example, some scientists think it could be causing subtle shifts in the tilt of the sun's axis, something that has puzzled astronomers for years. There's also the question of why the inner edge of the Kuiper belt seems to have a sharp cutoff. Normally, you'd expect objects to be spread out more evenly, but instead, there's a sudden drop-off at about 50 astronomical units, AU, from the sun. Some researchers believe that if Planet 9 exists, its gravity could be shaping this boundary. Step 5. The role of future telescopes. Despite all this effort, Planet 9 remains unseen, but that could change soon. Several new telescopes coming online in the next few years could make all the difference. One of the most exciting is the Vera C. Rubin Observatory in Chile. Scheduled to begin full operations soon, this observatory will take incredibly detailed images of the entire night sky over and over again. By continuously scanning the sky, it might finally spot the slow movement of Planet 9. Unlike past searches, which relied on looking at specific regions of the sky, the Rubin Observatory's approach is much broader, making it one of the best chances we have of finally confirming or disproving the existence of this mysterious planet. So, where is Planet 9? Despite all the evidence suggesting that something big is out there, scientists still haven't found direct proof of Planet 9. Some researchers think it might be hiding in the densest part of the Milky Way's background, making it difficult to pick out from distant stars. Others suggest it could be much fainter or colder than we expect, making it nearly invisible to current telescopes. For now, the hunt continues. The search for Planet 9 is one of the greatest mysteries of modern astronomy, and solving it could reshape our understanding of the solar system. Will we find it in the next few years? Or will it remain one of the great unsolved questions of space? The answer could be just one telescope image away. The evidence, tilted orbits, clustered Kuiper belt objects, and gravitational anomalies suggests that something massive could be lurking in the outer reaches of our solar system. But without direct observation, Planet 9 remains just a theory. Whether it's a hidden giant or just a trick of gravity, The search is pushing the boundaries of what we know about space. And if history has taught us anything, it's that the universe always has surprises waiting. The next great discovery could be just around the corner. So, is Planet 9 real? Right now, we don't know for sure. But one thing's certain. The search for it is making us look at our solar system in ways we never have before. And in the process, we might just uncover something even more unexpected.